I'm Teddy Gartland, and this summer I worked with Corina in improving object tracking for her human-robot collaborative project, in which Baxter assists a human in building a chair. And so the first few days here, I just got familiar with the pre-existing system that Corina and Alyssa already had in place. And at that time, we had two ways of tracking objects. The first was phase-based for the larger objects, like the two parts of the chair. And for that, we put small sensors on the objects, and we have a series of 8 cameras on the sides of the room that detect the sensors and then give us the coordinates in 3D space. But due to the size of the sensors, we can't use that for the smaller objects such as the screws and the screwdrivers. So for that we use computer vision to track the objects via color, and then to get the 3D coordinates of those objects we also use a depth map. And so as I mentioned, the current object tracking system tracks objects by color, and this is not very robust for a few reasons. The first is it is very dependent on lighting. If the lighting changes, you have to retune for the certain colors, and that can be tedious and long. And also it gets confused by background objects of a similar color. For example, the light gray tables in the room get confused for the blue pegs, and the green rug gets confused for the green pegs. So I set out to change this, and I started doing some OpenCV tutorials in Python. And I started out with very basic things like opening images or saving video to file. But eventually I wanted to write a script, find specific objects using their contours. And I would compare a frame of the video, the contours in a frame of the video, to a pre-existing array of contours. And if they match, then I would draw them and output their coordinates. However, I met with a PhD student in the graphics lab, and he suggested that instead of trying to write my own script, I find an open source software that does the same thing as I wanted to do. And so after some research, I found the YOLO neural network. It stands for You Only Look Once. And it is able to track and classify objects in real time, as well as track multiple objects at once. This was very appealing to me because many of the other object tracking softwares I found can only track up to like 2 or 3 objects at once. They would need to track 7. So I got to work retraining the neural network for the objects we needed, and this is the part of the summer that took up most of my time. We had to retrain YOLO to track 4 different object classes. So we have the pegs, the nuts, the screws, and the screwdriver. And so I had never worked with any deep learning or machine learning algorithms before, so this summer also gave me the opportunity to learn about that. And in doing that, I learned about the different parameters that a neural network takes in and how to adjust them properly. For example, by looking at the cost of the neural network, I adjusted the learning rate. If the cost was going or decreasing too slowly, I increased the learning rate. Or if the cost was increasing or doing some other weird stuff, I decreased the learning rate. And then I also adjusted the batch size to find how many images it could load into memory at once. So I adjusted these parameters to try to get the optimal training results. Unfortunately, after multiple training sessions and many different sets of images, I was unable to get any satisfying results. It had problems both with detecting the correct objects as well as many false positives. However, as you can see here, when it's very close up, it is able to correctly detect and classify the screw. But when you zoom out to the distance we need for the project, it is unable to detect any of the objects and even see some parts of the rug as objects. So some possible reasons for this poor training would be that I had a relatively low number of training images, only about 150 per object, due to the time it took to take the images and process them for training, as well as the increased time on the network. And we were also forced to use a smaller model of YOLO because we only had a graphics card with 1 GB of graphics memory, whereas the full version takes up 3.5. So we had to use a slightly smaller model, which also decreased the accuracy. So if we were to try to improve the training, we need to take more training images as well as train it on a more powerful computer with a full 3.5 gigabytes of graphics memory. In addition to retraining the neural network, I also did video coding on trials of building the chair, and I used Anvil to do this, and I labeled the hand behavior, so the actions that the hand is taking. As you can see, it's the top track right here, something like reaching for an object or picking it up or moving it, as well as the object status, so whether the object was being used or acted upon. You can see that down here, everything is no, except the screwdriver, which is being reached for, picked up, and moved. And so in the future, if you still want to continue to try to improve the vision system, I can see 3 possible options. The first is to continue to use YOLO and try to improve the training. As I said before, you need to take more training images as well as varied images, so images with different backgrounds and images further away, as well as have a computer with at least 3.5 gigabytes of graphics memory, so you're able to utilize the full version of the model. You could also try to find another open source object tracking software that is able to detect and classify objects in real time and track multiple objects simultaneously. Or you could also just improve upon the current color tracking system that we have now. Some possible ways to do this are to set a specific region to scan so that it's not confused with the table or the rug very far off. You could just set it to scan things that are on the table. Or you could allow for tuning in tighter HSV ranges so it doesn't get confounded with the other objects. I want to thank everyone in the lab for giving me the help and support this summer and allowing me to work with you guys, and especially Corina and Adissa for helping me when I needed it. Thank you very much. Any questions?
So you worked with a pretty complex code base, right, for this YOLO application. What did you find was the most challenging thing about doing that and getting it to work?
I'm just learning about the neural networks and how machine learning was done. It was a pretty big challenge for me if I didn't have any experience with this before, like I said. So I had to do a lot of independent research myself. Exactly how it's done, sort of what everything means.
Let me ask a different question.
Yes.
So, anytime a neural net fails, the answer is always, well, it just needs more training, more network. Okay, you need a bigger network, you need more training samples, right? And that's sort of the lure of neural nets, is that you can always sort of say, well, we just need more. If I told you you had to restart this entirely from scratch and not use a machine learning technique, how would you go about finding and tracking those objects? What do you think you would try doing first?
Well, I could try to continue the like contour detecting program that I was working on first.
Yep.
And fully flesh that out, see if that had any success, and try to improve that to be fast and very robust.
Thanks.